Hey everyone, thanks for joining us. This is Alan Schimmel, CEO, co-founder at Techstrong Group, the people behind DevOps.com, Security Boulevard, Cloud Native Now, Techstrong AI, Digital CXO, and of course Techstrong TV. I personally am also one of the co-founders of the DevOps Institute, which is now I'm proud to say, part of PeopleCert, worldwide leader in certification and training. And welcome to one of our PeopleCert Skill Up sessions powered by Techstrong. Today's Skill Up session is how to successfully implement continuous testing within a DevOps pipeline. And it's part of a theme that's been going on all month within DevOps Institute around continuous testing and DevOps pipelines. And we're very happy to have one of the DevOps Institute ambassadors joining us today. His name is Abdelahad, or Ab as we call him, Sator, and we're going to meet him and we're going to meet Ad in 1 second. But first, let me introduce you to another panel member we have joining us today, and it's none other than our Chief Content Officer here at Techstrong, and that's Michael Vizard. Hey, Mike, how are you?
I'm good, guys. How you doing?
Good. Thanks for joining us today, Mike.
Happy to be
You
here,
want to give a little background on yourself? Go ahead.
I run a lot of the content for DevOps.com and do a lot of the coverage, especially around continuous testing. So I'm looking forward to having a chat about where this is all headed because, well, testing is changing more now than probably any time in the last 2 decades.
Yep, I think AI and automation has really taken hold here. And when I say AI, I don't necessarily mean generative AI for all of my AI aficionados out there. But AI, ML, AI kind of stuff is really taking hold. Let us now introduce you to Abdelahad and it's Ad Sator. He's a senior solutions architect. Ad, welcome. Welcome to our webinar today, our learning session today. Why don't you give people a little bit of your background? I see it's up here on the slide, but go ahead.
First of all, I'm joining DevOps Institute like ambassador, and soon I will be like HashiCorp also ambassador. I'm owning more than 52, like it's 54 IT certification, like Kubernetes, like in the cloud, and like in DevOps, Linux, etc. And I founded like 4 companies before, like starting to 2010. And I filed in 3 companies. So I went in bankruptcy. And then I worked a lot like freelance, like independent consultant. I managed more than 30 projects and like with different team size. I had more than 20 consulting missions, like in freelance, and I delivered more than 80 technical trainings and web seminars. So, and now I'm working like a senior solution architect in SEMA CGM, and and we are implementing like mini standards, and we are rigorous for anything like related to testing, to DevOps, to HLD and LLD, like architecturing, etc. And welcome everybody. I hope it will be I will be asset to this presentation and with useful tips and tricks.
Excellent. Thank you, Ad. All right. Let me, first of all, hello to all of our participants out here. I see many of you are logging in and saying hello from wherever you are in the world. And we have people, it looks like in Germany, Virginia, St. Louis, Texas, always someone from Texas. But, hey, if you're out here, take a moment, log in, let us know where you're from. The way we run these roundtables here as part of our PeopleCert Skill Up sessions is, we count on the audience to be involved as well. Ad is our resident expert. It's from the DevOps ambassadors. But, this learning session is really about you. And as we're going on, Ad has prepared some slides here for us, and he's going to be talking about, implementing continuous testing within our DevOps pipelines. But if you have any questions or comments, please use the chat section of your big marker communications window here, which for most of you is in the right-hand corner of your web browser. We have someone from the Ukraine. Welcome. So please, feel free to comment, ask questions. We'll do our best to incorporate that in here and get you the answers you're looking for. I'm going to ask you to kind of jump in here. And, the first, as you put it up here, the first section is all about harmonization, right? And why don't you take it from here and maybe explain a little bit about what you mean by that?
Yes, because this topic, it's very large because like before talking about pipelines, about continuous testing, first of all, we should talk about what is testing. And most of the people or the companies today are trying to go quickly to what we call it tools or technical solution. Like for today, we are talking about ChatGPT, prompt engineers, but it's just tools. What we should know is the basic. It's why we are testing. What standards? What real testing? Why I will talk about integration testing, and I don't know like what is testing level like against what we call it CLCD cycle of testing, like and what is test technique, what is black boxing, what's white boxing. Because if we don't know this, after 10 years, we are using tools like Checkmarx for DevOps security, etc. Like we will always be in the same level, like or for background skills, because we are just using tools. So in this webinar, it's more about fundamentals, and in the same thing about anti-patterns and high level expertise, and about also talking about market tools. So I try to harmonize all these things. So this is what the slide tried to show. Yeah.
Okay. Well, let's jump in here a little bit, right? Debunking myths of testing and continuous testing. So there are, I've been following this a while. Let's talk a little bit about the myths of continuous testing.
For example,
you got them up here.
Yeah, some of the most famous. For example, we think that TDD, test-driven development, is for unit testing, for example, and BDD is for functional testing. The third one is that we think we are testing to have free bug, for example, to have software with free defect, free bug, free error, and this is the first mistake, like in CBQ, like standards, and that we can automate everything, and that manual testing will disappear. Because recently we're talking about prompt engineering, we're talking about IA testing, plat ops, etc. But we think that manual testing, it's something that replaces automated testing, but it's just two kinds of what we call it static testing. That's different. If you write good code, you will not need tester. No, because we have separation of concern of responsibilities. Because yes, we can shift into left, and tester can, yes, and developer can test, yeah, and do tests, yeah, but he has responsibility of testing code, yes, but developer doesn't know about tracking management. He doesn't know about defect tracking. He doesn't know about management quality assurance. He doesn't know about many advanced knowledge about testing. And the developer also, he can't code and do what we call it strategy testing of the company, how to implement it. Also about record of testing, about scripting, etc. And so we need always testers. Anyone can test a software application now. Testing needs really basic knowledge. It's like coding, for example. We should know about paradigm, we should know about PEO, etc. It's the same as testing. It's just like a very big framework. And testing is easy now. Testing is the most hard things to do because we analyze a lot. And when I said it's not easy, I'm not talking about TDD. I'm talking about testing, about quality assurance of software. Any developer, yeah, go ahead.
Yeah, if I may jump in here, I think, when we talk about popular software testing myths, the biggest myth was that somehow between DevOps and automation and continuous testing, we were going to replace testers. Testing would be obsolete. A test engineer would be obsolete, and that the developers would be doing, the developers would be doing the testing. Developers develop, testers test. Yes, we can write some automated scripts which a developer can kick off as part of their testing within their CI/CD pipeline. But even choosing what the test coverage is and what scripts to run and what tests to run still resides within the realm of the testing engineer or the testing professional, not necessarily the developer. And I think that's a lesson we've learned over 10 plus years of DevOps experience, right? Is that there's a place for testers. As a matter of fact, with all of this continuous testing, we need more testers, not less testers. We do have a question from the audience, though. TDD is for unit testing, BDD is for functional testing. Odd, I just want to make sure we don't have a problem with the English. Are those myths, or are they facts?
TDD is approach. And TDD, like for example, I will go directly to the show slide. Okay, I will just check it to go.
If you don't mind, go ahead.
Yes, because I'm going to. Okay, I will jump this question. Okay, I will wait because I will answer that in the slides.
Okay.
Because it's like let's first talk about standards. Testing has standards because it has standard about software testing concept, about process, about documentation, about how we should review the process and description, what should contain the description of test technique, like about coverage, measures, etc. So everything is like standardized already. And the problem today that we think and design with problems that you should think and design with problems and process, and not what we call it technology and technical solution, what we call it design by implementation. It's like what's happening now about the confusion about TDD and BDD. And for example, if I talk about Gherkin, everybody is doing about Gherkin for Cucumber, etc. It's Gherkin language, functional language, was for the first thing made for unit testing, and not for functional testing, and not for system testing. It was made for unit testing, and we use it for unit testing too. So all these misconfusions made me making this presentation. And first of all, we should know what is testing before going to continuous testing and pipelines. Because if always we confuse this, we will only be using a bunch of tools chain, like making Jira here, like making this here, we are just collecting tools and we are not doing testing. And that's why testing sometimes doesn't fit for the companies, and always they find the defects and errors, and they find that they are spending a lot of money for nothing. And that's why a developer thinks that we should not test. So introduction to testing. So why we test? Everybody now, because always we have safety critical systems like plans, like for medical systems, for softwares, etc. And we test also to master the code, to maintain the quality of code, to control the code. It's like what we call it pull request for co-peer programming that we use for agile, to be more agile in the manifest. We do it here. When you test your code, when you try to break your own code with testing, you control it more. And also for anticipation bugs and compliance conformism. And in this presentation, I will list many areas to go quickly, because I cannot go in detail, and you will have the presentation at the end. And here many statistics talking about voilà, yes, here it's like talking about a lot of loss today about because of testing, or because we are doing testing just because people doing it. Introduction to testing, like always, test every timeline of calls will bring one bug. This is axiomatization about testing. So what about 1,000 of calls? Who is the owner? And what about if developer quits the company? So these mistakes, lack of experience, I don't know, misunderstanding, time pressure, anti-pattern, we're dealing with complexity, make us make errors, and this error manifests in softwares. And if it manifests in softwares, we call it faults or defects or bug. So in the runtime, if we find it, we call it failure. So testing, like imagine that I have more than 20 screens, and for this screen we have the average 4 menu, 3 options menu, and I'm going to the screen and have the average 10 field screen, 2 types input field. That's the first is that date as January, etc. The second is number. So we have around 100 possible values. So if we made calculation about testing everything, that's why not just testing everything? Absence of error fallacy. So we need like just to for this system that has 20 screen, we need 40 years like to test it. So that's why we don't test everything. So we test what? We will see. So now let's talk about the test process for different level. We have 4 levels. The first is test policy company level. For example, compliance. For example, we can make tests a bench of tests. We call it test compliance. It's like unit testing or integration testing, but we cannot call it compliance testing. It talks about, for example, the naming convention in the company. This test should be implemented on a high level, and this test should be broadcasted to all projects and should be reused. The test strategy, for example, if are we going to use like we are going to test like against browser and iPhone, I don't know. So this is company level and we can reuse it also. After that, we have a high level test plan, and this is for the projects. And detailed test plan is the stage level. That means it's not for the high level testing. It's not for this, because this is for the whole projects. But this is for all the project detailed. It means for components, for system, for unit testing, etc., etc. And before doing test process, the first thing that we are doing is the planning. We don't just go to test. We don't just test because it's a part of what we call it Scrum sprints. Now we test before any test in any level, like company level, test policy, test strategy, high level, detailed level. We should do this. First thing is specification. Then we go to the execution. Then we go to the recording. Then we check completions. And if we are not satisfied, we go back to specification from the beginning. And this happens more often with regression tests. But in the DevOps, what we call it the third way of theory of yes, the third way, it's looping strategy for everything to have feedback from testing. So I will go quickly like for what is specification. So specification is to identify conditions, to design test case, to build tests. How we identify conditions? How do you know that you are going to use TDD here or BDD, for example? This is designing test. How we identify condition? What we are going to test? Void? Which range of data? Exceptions? Communications? Etc. So test for this like specification for designing test, we should be like it should be effective, finding faults, and represent other, easy to maintain and cheap to use. Then for test, always for test process and for test specification, how we identify conditions, it should first of the all say what is to be tested and prioritize. Prioritize, yes. And this we have like many of theories about how to prioritize. That's why you should be with software test engineer. It's not your task. It's a co-programming task between you and between the product owner and the tester. And tester know about all the standards, what we should test. It's every fields, it's every data, it's etc. Most of the time, we try to select the test condition from the importance and not the first set that we find. That's why we use TDD here. So, for example, we test, and after testing, we found that it broke our test. The second wage of a range of testing here, and we try to find the most importance by business case, and this our sets. The second tense, it is second tense about test specification is to do the design test, and design test inputs. It means like what should the inputs have to be, and what's the test data. How we should determine the expected results. For example, for product outcomes, it's easy for softwares, but how about cloud? How about Terraforms? About edge computing? How about Kafka? What's the expected result? It's asynchronous, etc. And then we design the set of tests. The final one is to build tests, and we should, before of building tests, we should prepare test scripts, and this is the task of software engineer: prepare test data and prepare expected results, and it should be like confirmed with the developers. And here we should be aware of many patterns like false positive, false negative, etc. And then we execute. The most important ones first. We do not execute all test cases, and we can perform this test manually or automated. And if we go back, like in the slide, we will find that after this process, we say the test specification, then the test execution, then we should record the testing. And record the testing, it means, for example, the history of the track and of the stack, that all tests have been executed, not executed successfully or with failure. We record it, we do test again, we record what we call it preview incremental testing, and then when we compile, we will have the coverage of our testing. So it will be sometimes like test for specific. We specify, we execute, we record, we check completions, and the more we do with this loop, we are in the DevOps principle, and the more the coverage we will have, and the more better conditions testing and better design testing choice.
Very good. So, Odd, I have a question, if we may.
Yeah, go ahead. Yeah.
So, one of the unique things about DevOps and DevOps pipelines, and it's actually one of the principles of DevOps, is feedback loops, right?
Yeah.
So in other words, we don't just release once. We're the same way we're testing continuously, we're almost deploying and releasing continuously, right? Which doesn't mean we're releasing all the time, but we're doing it continuously. And what we're supposed to be doing is taking in feedback loops from what we've developed, and then, and what we've released, and then incorporating that into the next iteration. We iterate, we reiterate, we iterate. How do we incorporate those feedback loops and those testing loops into our pipeline here?
Yeah. Let me introduce before this something that's very important in testing.
Okay.
What we call it testing throughout the software test cycle. So what I presented about planning, testing, and the process, we should do it here. We call it acceptance test for user requirements, for system requirement system test, high-level design for integration test. And remember that high-level design, it's related to the projects, and low-level design, it's tied to the component testing. And this is the implementation of all this testing. All this test, when we do it with the right strategy, etc., then we can talk about the continuous testing. And the continuous testing, it's just a process that enable us to not break the testing cycle or the development cycle. It does mean we should make marriage between testing and development at the same times, without breaking development when I stop testing, and when I stop developing, I will not break the testing. This is the first thing. The second thing is that I should have feedback in real times. Why I will have feedbacks? The principle is not the coverage. The goal is not the velocity. We have other advanced DevOps metrics like MTTR, like wipe, like for example, what's the cycle time? For example, like what the time that takes from me to develop user story from the beginning to the deployment, or what's the time that take me to make the first error, or for the deployment, what the time that take me, for example, to correct and redeploy for regressions functions. And this enable me to have a lot of data. If I have a lot of data, I can scale my team quickly. I can know what is the competency and the skill background that I need for my teams to make the best testing. And also I can connect via the API, because I have doing continuous testing. It means I'm testing, I'm tracking every time. And I not need testers to do some things, or the developer to tell me go and make testing. Testing is for the system design, it's doing every time. For unit testing, every time I'm making one line code, I'm redoing testing. And all this data tracking management can give me very advanced with using like internal artificial intelligence, many coefficients and many KPI tools that I can give to my client, to my directors, and also for me to improve, because the first principle of DevOps is to continuity, to improve. If I'm using testing just to say I have 100% coverage testing, this is not the real goal of continuous testing. And with many organizations like DevOps and DevSecOps, we automated the principle and the frameworks that we should use to use the best continuous testing framework that create for us pipeline. So here, what I presented from feedback and test data, I will run my machine again from the beginning, and we should be always using data, and which should be corrected. And this is what we call it continuous testing, because it's related to always to the release projects that should be deployed and operated. Then we monitor the operations. And what does mean? That means I built websites, it's run, but I'm using tracking. I'm tracking, for example, for EBA testing. I'm tracking, for example, if I have defects in the interface, graphic interface. And this all monitoring make me plan, what we call it planning testing. And this planning testing make me to choose what I should be test in this iteration, and what I should enhance and correct. Then I code, then I build, then, and this is an infinite loop. So how to accomplish continuous testing? There are many principles, yes, it's many what we call it manifest. The first thing is to shift testing to the left, because more I test early, more I find things to optimize. So I should save time and money resource by optimizing testing process and test coverage. And this one is the most important, is to get robust data with real world character. It means with real time testing. I made other manifests here, and I will go directly after finishing all of this. I will find myself with pipeline for the first time, because what's pipeline is just a bunch of tools for my CI/CD, for my continuous testing. And my continuous testing here is just a part of what we call it continuous integration. So here, I will have finally what we call it continuous integration. That's here. That's have continuous testing. And if I'm doing like deployment pipeline, we will call all this is the continuous delivery. But if we don't automate the delivery, for example, to deploy, and we will just, for example, automate the unit testing, integration testing, system testing, etc. We will use just, we call it continuous integration. But maybe it's not continuous integration, because if you not have this loop back, like we record test, we try to improve, we have in the next sprint things to improve. I'm not talking about creating new code. I'm not talking about a new feature. Now, just every time we test, we find some things to renew, to optimize, because we have maybe the load is 30 milliseconds and we should have 100 milliseconds, etc., etc. And this, I found this, it's very famous in internet today. So if we wanted to imagine our pipeline, we are doing the planning, we code, and all this is via tools like Jira, Slack, etc., GitHub, pull requests. We build our project with Jenkins, with PlatOps, in the cloud, with low code, with no code, etc., and we package it with Kubernetes, without Kubernetes, with Flatjar, with containers, and all this is what we call it continuous integrations. Then we do testing. And testing, it's all about what we're talking about. It's about system design, unit integration testing, unit testing, and low-level testing. We do it as with our budgets and with our target, or with non-functional requirements. So then we have continuous deployments, because I will not say, hey, I will make mini scripts and I will wait someone for Saturday to deploy my software. So it will be always a loop here, a loop here, and a loop here, and a big loop here, like explained here. Yes. So this is the most trending pipelines. At the end, I will have plan, trace analysis, results, code. I will test with static analysis. For example, SonarCube is doing what we call it static. Then I will be.
Oh, I think we might have, Odd might have had a drop there.
I think part of the challenge with all of this is, I think everybody understands that there are stages, but when you start doing this at scale and you need to orchestrate all this stuff, it becomes really challenging, because now I'm going to have different workloads and different microservices or whatever they may be at different stages. and then I'm trying to run and manage tests across this. So I think part of the challenge is, we need some layer of abstraction that sits above all this that automates the processes based on what's happening in the pipeline. And I think that part of it is missing in a lot of organizations. Alan, I don't know what you see.
I see the same thing, Mike. But look, here's the good news. There are solutions though that do help you automate it. I think Odd is not wrong in what he's saying. I think the problem today is testing has become an umbrella term. And here's Odd back. Thank you. Testing's become an umbrella term for so many. It's beyond unit testing today and so forth. Security is part of testing. There's so many. There's the user experience testing, optical testing. Testing has grown and morphed into this multi-headed monster, and without some sort of orchestration, without some sort of testing czar, it's very hard to get your head around all of this. Odd, are you back?
Yes, go ahead. I'm hearing you. Yeah.
Go ahead. We were just filling in here while you were out. I'll let you continue with your presentation.
Okay. Okay. I like, yes. So let's talk about pipelines, and then I will go back, right?
Okay.
Yeah. So what's pipeline? As we said, when we are doing continuous integration, it's moving alone. Maybe because of internet. Are my voice clear?
Yes, we're hearing you fine, Odd.
Or you lost me?
No, we hear you. I think Odd is having issues.
Yeah, you lost me. Yeah.
All right. Well, we see the slides and we kind of hear Odd, but one of the things that I think is also happening with a lot of the tests.
Okay.
There we go.
Odd, can you hear us? I don't think he hears us, Mike.
All right.
Technical difficulties, but what were you going to say, Mike?
Let me finish the thought. I think what is also happening on the shift left is a lot of the routine tests are being run before developers or as they write their code, because the issue has always been the developers didn't really know how to create the tests. So if we create more of the basic tests that they run before it hits the pipeline, the better. But that doesn't obviate the need to run the tests within the pipeline, because multiple developers are adding stuff and things can happen in the build process. So I think ultimately, though, we may wind up with better applications because we're doing more testing starting earlier, but it's not an either or equation in my mind.
So I think there's no doubt that we have better testing than we did years ago, right? Because quite frankly, before the concept of continuous testing and automation, it was always a struggle. I know in companies I founded, right, we never left enough time or budget to do testing adequately. That's the truth, right? Now with the advent of continuous testing and automation, we have better coverage for testing than I think we ever did. And the fact that we can kind of architect what the test coverage will be and then implement these tests in an automated fashion works. I think, Mike, what you got to understand, and not you personally, but our audience has to understand, is that when we talk about a DevOps pipeline, it runs from left to right in there's various stages. Saying that the developer is doing the testing upsets me. Developers have enough on their plate. I don't need developers to test. I need developers to maybe kick off a test. But that test was scoped, scripted, planned by a test engineer, by a testing individual, right? And the developer, whether that test takes place in like in a GitOps atmosphere, right in Git, as the developer is putting the code in, into a repo, it gets tested. Or maybe it's right within his IDE. We've seen a lot of this now. Testing being done in the IDE, testing being done in Git, and then of course, testing being done prior to deployment, right? Yet another round of testing, if you will. So I think when we talk about implementing a continuous testing strategy within that pipeline, we have to acknowledge where along the pipeline are opportunities to test.
Mm-hmm. I think part of the issue too is historically developers got wrapped up in their heads that said that, well, if there's any issue, we'll just do an update to the app and we'll fix it immediately. But I think the tolerance for that among end users is dropping to zero, especially in the mobile world. I mean, most end users are like, if this thing doesn't work right in the first 4 seconds, they move on and they don't use it again. So I don't think we have the luxury to quote unquote experiment on end users the way we used to. And I think that's putting a premium on testing at multiple stages across the way, because we can't just wing it anymore.
Well, that's the argument for pre-deployment testing, right? You got to shift that testing left. Mm-hmm. But I think, part and parcel, and we mentioned the enhanced scope of testing and the different kinds of tests we do beforehand. But it really comes down to, though, your test coverage, and it always has, right? If you leave enough time for do the right testing prior to deployment, hopefully you have a higher quality product and less, whether you want to call it beta testing or, testing on a live audience, whatever. Obviously, no one wants to do that. The good news is there's a lot of programs out here where we that are doing this kind of thing. Mm-hmm. Whether you're using, and this is another thing we didn't discuss. I think Odd mentioned Jira, but that's not really a CI/CD program. That's more, it's a different animal. But whether you're using Jenkins still, and many of us, most of us still use Jenkins. Right out here, it's still probably the dominant CI/CD platform, mm-hmm. or you're using a GitLab or a JFrog pipeline or GitHub or any of the many different pipeline tools out here. They all integrate with today's leading testing. The other thing I would mention is so much of today's testing is open source based, mm-hmm. which allows for. There's no excuse about how expensive it is or anything else. It may not be easy, but they're built into these pipeline tools. And I think that's another important thing, is make sure your test coverage is correct for the CI/CD pipeline tools you're using.
We are seeing the rise of AI and machine learning algorithms, and I don't think they're going to replace testers anytime soon. But what we are seeing is that I can conduct more tests in a shorter window, and I can get the right test at the right spot at the right time. And if I can do that, then I'll be experimenting less after I put things in production. So, I think part of the issue has always been that the level of cognitive load to kind of orchestrate the testing process has been too high for the normal average human. And we're going to need some machines to help us out with this stuff, because there's just too many moving parts.
Absolutely. Hey, we only have a few minutes left, but from the comments, I think Odd is back on. He's at least able to chat. Odd, can you hear us now or no?
Yes. I was hearing. Yes. Yeah.
Okay.
Yes.
Mike and I were doing our best to fill in here for you, but what do you think, Odd?
What I think it's always the same thing. It's that we should not try to define our tools with just those technology. We have IA, we should implement IA. Why you will implement IA and you are not doing the test correctly? Why you are doing IA, or for example, continuous deployment, and you didn't finish continuous testing, for for example.
Yeah.
While you are testing, and what is your budget for testing? And before budget, what is your strategy for testing? I know many big companies like Stack Overflow, they are doing like the whole of testing manually. We don't have problem with that. The automation is not the solution. The solution is you should know what you are doing in any stage. This is the first thing. The second thing is what we call it learning behavior. You should have learning behavior. You should improve things. And to improve things, you should have feedbacks. And to have feedbacks is just to compare your testing in every stage and analysis of make very analysis and make like map analysis between every stage. And this is the role of test engineers. That's why very skilled test engineers have big salary than very senior software developers, because it's like data engineering or like data analysis. It's a kind of science of data science, really. And for the second question, for example, why the deployment, continuous deployment is hard? Because here, for example, we are having many distributed microservices with asynchronous things, with things maybe in promise, other things like depend to the first component before it should be up. And because also we have what we call it SRE.
Understood.
Site reliability engineers. We have from the plan, we have what we call it SLA. And this is the things that we have designed and things that we have in the first requirements. And with the SLE, we'll have here what we call it SLO. It's what we call it service level agreement, level objective. And service level objective will define what we call it service level metric indicators. And this, we should respect it. For example, we should have the website up. That means we are talking about scalability. So we should deploy Kubernetes. So we have problem with DNS. It's many level here that we should use in technology than here. That's why it's very difficult, because here we can use tools. Here we should be very careful, and we should be we should have really real feedback that things work. For example, I was doing Kubernetes, and Kubernetes said, yes, it's work. I deployed it, but in reality, it was not working. It just the container was replying me with okay, with HTTP 200 code status, but it's not working. Which I should define it in the design testing here, and it should be implemented here. And this we call it smoke testing, or real-time testing, or monitoring. And for monitoring, for deployment, we monitor, and we use a lot of environments, like quality environments for regression testing. We use like UAT for pre-prod testing, and we use prod testing, and we use what we call it capacity testing, load testing, and a lot of testing to make sure that our platform works. And it's running now, and I should always give the feedback here. It's running, and I should give feedback here. So it uses very advanced concepts. That's why it's difficult, because it uses SRE and not DevOps.
Understood. Excellent. We're about out of time. I want to thank you. I know bandwidth today was difficult, connectivity was spotty, but want to thank you for coming on and giving us your insight into how to successfully implement continuous testing within a DevOps pipeline, as well as exploring some of the myths of this, and really laying out in a very good way the whole process, if you will. If it's okay with you, Odd, I would like to make available to the folks in our audience a copy of the PDF of the slides that you worked on today. And Cody, I'm going to ask you if you could maybe put a link up for that or something that we can get people so they can follow along. Because the truth is, Odd prepared something about 75 slides here that we haven't had a chance to explore. And I would very much like to make that available to the audience. Mike, if it's okay with you, I'd like to give you the last word, and we'll go from there.
I think that for all the advances that we talk about with orchestration tools and automation and AI, there's still no substitute for fundamentals. I mean, what Odd showed was you need a thought process and a way to think about this and a strategy. And there's just, a lot of people are still kind of winging it because they are, using tools randomly and they don't have a set of concepts as to how all these tools relate to each other and a workflow that goes around it. So to me, testing has always been that area of DevOps that gets overlooked, and yet it might arguably be the most important because, well, we are trying to build better software faster. So test more, test often.
Absolutely. Can never have enough. Hey, for those of you who may not notice, in the chat section, Cody has already put up the link to the PDF slides today, which you can help yourself to. They're under the handout section. So if you look in your communication window, it's chat, QA, polls, handouts. If you go in there to handouts, feel free to download the PDF for today. It'll be available. This whole webinar was recorded and will be available on demand on the Techstrong Learning channels. We encourage you to listen to it at your leisure if you haven't had the whole thing. Once again, Odd, thank you so much for coming on today. Appreciate your work and effort. Mike Vizard, thank you so much for all you do. And thanks to our friends at PeopleCert and the DevOps Institute for all they do to advance the humans of DevOps throughout the world. And join us on another PeopleCert Skill Up session soon. We talk about things like DevOps and ITSM and project management. Look forward to having you there. This is Alan Schimmel for Techstrong. Thanks very much. Have a great day.
Thanks, everybody. Yes. Thank you very much.
Thank you.
Bye.